Hello, we're going to look at rationalizing denominators today. So what that means is that when we have a fraction, we don't ever want a square root or a radical in the denominator. But that also can look like we don't ever want to have a fraction inside of a square root that we may have. So here's two different examples of both of those definitions. So here we have a square root in the denominator, and here we have a fraction inside our square root. So our goal today is going to be to get rid of both or either of these. So here is getting rid of the square root in the denominator. So what we need to do is to cancel off that square root. Well, in order to do that, we need to multiply by that square root itself. So when I multiply by the square root, I have to multiply by it by like square root of 5 over square root of 5, because technically that is 1. So we're not changing our problem. So here we multiply by root 5 over root 5. The numerator becomes 3 root 5. Then this 2 stays there, and then square root of 5 times square root of 5 is the same as square root of 25. However, we know that that is 5, so 2 times 5 is where I get 10 on the denominator. Whenever you take a square root times itself, it will always be that radicand, that number inside. So this simplifies to be 5, and that's where I get 2 times 5 is 10. Okay, here's the other type of rationalizing. We had square root of 1/8. However, I don't want to keep it as a fraction inside that radical. So I multiply by 2 over 2. Again, we're multiplying by 1, so we don't change our problem. The reason I multiply by 2 is because now my denominator is 16. And when I split this square root, there's a power or a square root rule that says I can take the square root of fraction is the square root of the numerator over the square root of the denominator. So now that I have 8 times 2 equaling 16 on the denominator, I split up my radicals and the square root of 16 comes out nicely. So now we no longer have a fraction inside a square root, and we don't have a square root in our denominator. So we're going to do a lot of focusing on the first definition of rationalizing. So here's another example. It's a bit more complicated than the one we started with. Here, we can't just multiply by square root of 3 over square root of 3 because we have this negative 4 plus. So we have to multiply by something called the conjugate. And our conjugate is going to look very similar to our denominator. However, our middle sign is going to change. So here's like your formal definition. A, B, and C, or A, B, C, and D are all just numbers. So if A square root of B plus C square root of D is our denominator, our conjugate is going to look almost identical, except for that middle sign will change. It will always be that middle sign and only the middle sign. So the key thing about this is when we multiply by the conjugate, all of our square roots go away and we just get a number, a rational number. So we're going to take this example, this 2 over negative 4 plus the square root of 3, and we're going to solve that. So we multiply by our conjugate over our conjugate. So negative 4 minus root 3 over negative 4 minus root 3. And then your just basic multiplication rules apply. So we're going to distribute this 2 to both pieces. So I get a negative 8 minus 2 root 3. The denominator we're going to FOIL. So we have a 16. Our outsides would be plus 4 root 3, and our insides would be minus 4 root 3. And then our lasts would be a minus square root of 9. And square root of 9 we know is 3, so that becomes a minus 3. In every single case where you multiply your denominator by the conjugate, these middle two terms will always have opposite signs and they'll cancel off. So that plus 4 root 3 minus 4 root 3 cancels. Our numerator stays the same, and then we would have a 16 minus 3 on the bottom for that 13. So here's another example, 3 over root 5 plus root 2. Again, multiply by your conjugate, which is root 5 minus root 2 over root 5 minus root 2. The numerator becomes 3 root 5 minus 3 root 2, and your denominator, like I said, your outside and your insides will cancel, which leaves you your first and your last, which is where I get the 5 minus 2. So we get a 3 on the denominator, and I went ahead and factored that 3 from the numerator back out so that we could simplify a little further. So then the 3's cancel, and you're left with a root 5 minus a root 2. Last example, here we have a binomial on the numerator as well. So when we multiply by our conjugate, we're going to have to FOIL the top. So I did that. When you FOIL the numerator, this is what you get. And your denominator, be very careful when we do our firsts. we get 4. Outside, inside cancel, so we're on to our lasts. Don't forget to multiply those two 3's out in front of your radicals. So 3 times 3 is where I get this 9. And then square root of 3 times square root of 3 is where I get that 3. So you have the numerator becoming 17 plus 14 root 3, and your denominator is negative 23.